Now, when we know that data is normally distributed, there are certain results that we end up looking up on our z-score tables more often than others. And those are the whole numbers. So if we're interested in finding out the probability of a score being within 1 standard deviation of the mean, or within 2, or within 3 standard deviations of the mean, it makes sense to memorize these results because it saves us from looking up the tables all the time, especially if we don't have them handy. So not only is it handy to memorize, we actually need to memorize them for this course because this is part of our syllabus. Now we call this the empirical rule because it's something that just holds true for all normal data. 68% of scores lie within 1 standard deviation of the mean, 95% lie within 2, and 99.7% of the scores lie within 3 standard deviations of the mean. Now you'll notice that these two are sort of rounded off. They're rounded to the nearest percentage. They're not exact numbers, and in fact they're not the exact same answer that you would get if you looked up the z-score table, but to the nearest percentage they're pretty close, and they give us that really good ballpark idea of how many of the scores lie within a certain number of standard deviations. Of course, we can't round this one to the nearest whole number, or we'd be saying it's 100%, and clearly it's not. So it makes sense to round it just to 1 decimal place. So let's put a big box around that in your notes. That's an important thing to know. And these 3 numbers are numbers that you need to commit to memory. Now don't forget what this means. It means that 68% of the scores lie within 1 standard deviation, sure, but that means on both sides added together. Now remember, 1 standard deviation is where we find the point of inflection on both sides of this curve. So if we mark off this area to just remind ourselves what it is we're talking about here, we're saying that 68% of all the scores lie in here. Now, there are times that you will be asked in a question to use the empirical rule to answer some probability question. And that might be because you're not being provided with a z-score table at all and you're expected just to use these figures. So there's a bit of a trick. You need to make sure you use your sketch as you would with the z-score and just slow down and think things through. Because if you've got 68% on both sides here of the mean, that means obviously that you've got 34% on each side, just halving 68. So if you're asked a question like, use the empirical rule, which means these numbers, to find the probability that a random variable has a z-score less than 1, you're going to be thinking about this 68, sure, but you really need to do a quick sketch, as we did when we were using the z-score tables, and reason that you've got your 34% on each side. So if you want the probability that z is less than 1, then you want this 34% here, but you also want everything that's shaded all the way to the left of the distribution. And so it's easiest to reason that this entire half is going to be 50%. So what you'll actually want then is 50 plus 34, which is 84% of the scores. Now there are lots of ways that you can figure out the same thing, as there are when you're using the z-score tables, but being especially careful knowing that you're dealing with both sides here is important. Answering a question like, what is the probability that a particular score has a z-score more than 3, means you should be thinking of a diagram like this. And if you know that you've got 99.7% of the scores in this entire middle section, that means that naturally you've got 0.3% in both of the tails put together. Now, if you only are interested in the size of one of those tails, obviously you need to halve that. 0.15% will be in each tail. And thinking that through with your diagram and even writing out your reasoning can be really helpful. So then the probability that a z-score is greater than or equal to 3, I'm just wanting the size of this tail up here, and there's only one of them. So that means I have 0.15%. But another person might work that out quite differently. They might say, let's halve 99.7%, and that gives us 49.85% in each half. So therefore, if I want just one of the tails here, and I know that one entire half is 50%, then they could do 50% minus 49.85 to get the exact same result. So there's lots of ways you can do it, and as long as you draw that picture and think through the size of each section, you should be right. So before we move away from the empirical rule, let's just double check that we understand where these important numbers have come from, the 68, 95 and 99.7. We can get these numbers ourselves from our z-score table, and let's just check that we can actually do it. If we look up the probability that z is less than 1, 2 or 3, that's just this first column here, and we get 0.8413, 9772, 0.9987. Now, a quick sketch reminds us what these numbers mean. This is the size of the area, or the probability, that a z-score is less than 1, and that includes the entire left-hand side of the graph up to a positive z-score of 1. Same here, up to 2 and up to 3. So then if we wanted to actually just find the size of this section here, that's actually to the right-hand side of the y-axis, or the vertical axis, it makes sense that we'd have to take that number and subtract 0.5 from it. So if we do that, we can literally write it down as 0.3413 instead of 0.8413. That's quite straightforward because we've just taken that half off. Same thing here, 0.4772 and 0.4987. Now these numbers over here are going to be the size of the section that's shaded orange. But if we want to look at now making that orange section twice the size so that it contains everything all the way from -1 up to 1, it makes sense we'd need to double that number. And here again, we'd need to double this one, and we'd need to double this one. And that's what we've got here with our orange figures. Now, as a percentage, this is 68.26%. Well, these numbers here aren't perfect. They've been rounded off to 4 decimal places. And clearly this isn't exactly 68%, but it's a decent estimate when we round it off. This one's pretty close-ish, I suppose, to 95, but it's really 95.4 something. So that's actually a little bit further away from 95%. It's not that close. And our 99.7, well, it's actually 99.74. So know that those numbers in the empirical rule are not exact, but they just give us a good ballpark figure and save us from having to look up tables for those really common results.